Welcome to the new session. In this session, we will talk about the derivatives of a function. And we know that we have already studied the concept of limit to introduce the idea of derivative, which is useful in constructing various mathematical models that can be translated into some meaningful applications. The process of finding out derivatives is a mathematical tool or technique of exceptional power and veracity. It is one of the two central concepts in the branch of mathematics called calculus and has a variety of applications in including curve sketching, analysis of rate of change, optimizations of functions, and then marginal analysis, right? So in fact, in this lecture, we will study how the derivative of a function is being calculated. We will use the concept of limit, which we have already discussed in the last few lectures, because the concept of limit plays a very prominent role in finding out the derivatives of the various kinds of functions. Let us take the initiative process. Derivative or differential coefficient of a function. So derivative or differential coefficient of a function means derivative is what a function whose derivative we want to calculate, right? We can also call it as differential coefficients because in different books, different terms are being used. Suppose y is equals to fx. This is a function. Please recall about the function in the last few lectures we have already discussed. Function is what here y is equals to fx means y is a function of x. It means what? Here this x should be taken as independent variable and the y should be taken as dependent. And you all know from the definition of the function that if any change in the independent variable is being done, the corresponding change in the dependent variable will be also noticed. That is why this is called a functional relationship in between two variables x and y. So the same we will do here. Let y is equals to fx be a function. Let delta x be an increment given to x and delta y be the corresponding increment in y. The first thing is what? Don't be confused or don't be scared off with these two new terms, delta x and delta y. This is the notation of delta x and this is the notation of delta y. So delta x and delta y we are using just now, but later we will remove these two terms. But here they are used as standard notations almost in every book. That's why we are also using it. So what is delta x? In fact, delta x is a very small change in x. Very small change. For example, if I say I have taken x is equals to 5, right? The value of x is 5. Then what is delta x? So delta x is taken as, for example, 0.001, right? So if we add these two, x plus delta x, what you will get? 5 plus 0.001. This will be equals to 5.001. Clear? Likewise, delta y. A very small change in y. So delta x simply refers to a very small change, a very small increment. Increment means addition. So delta x simply represents a very small change in y as explained here, right? So if we will make any change in x, we know by the definition of a function, the corresponding change in y will also be noticed. So if x is changing from x to x plus delta x, then naturally y will also change. Say y is changing from y to y plus delta y. Delta y is the corresponding change in y. We take this as equation 1 and this as equation 2. Now, from these two equations, we will proceed further. Subtract equation 1 from equation 2. What you will get? Y plus delta y minus y Y and y will be cancelled out. What is left? Delta y is equals to f of x plus delta x minus fx. This equation we will get, right? After getting this equation, what we are going to do, divide both sides of this equation by delta x. So see what we will get. This we will get delta y over delta x, and this is equals to f of x plus delta x minus fx divided by delta x, right? This is about this equation. After getting this equation, the next step is what? We will take the limit delta x tends to 0, right? I have told you we will use the concept of limit to find out the derivative of the various functions. In fact, the concept of the limit play a very prominent role in finding out the derivatives of almost all the functions. So in this equation, taking limit delta x tends to 0 both sides. So look at here, delta x tends to 0 in the left hand side, this term, and delta x tends to 0 at the right hand side, we will get this term, right? So the right hand side is now okay. We have nothing to do with the right hand side further. This is more than sufficient. What about the left hand side? This left hand side, we will calculate the limit of the left hand side by using the methods of finding out the limits available, or what we have already discussed in the last few lectures. But this is not in your course. This is beyond the scope of your content or course. When we will find out the limit of this function, its value comes out to be dy over dx. What does it mean? It means limit delta x tends to 0, delta y over delta x. When we calculate this limit, this comes out to be equals to dy over dx, right? So this dy over dx is the main thing which we want to calculate, right? So this exists. If this exists and finite, then it is called the derivative of y with respect to x, and it is written as dy over dx. So this dy over dx is called the derivative of y with respect to x, right? Be careful. Derivative of y with respect to x. This means y is here a dependent variable and x is here independent variable. So we always calculate the derivative of a dependent variable with respect to independent variable. Variables may change. You can change x and y from p and q, but we will always write down the derivative of a dependent variable with respect to independent variable. So dy over dx is called the derivative of the dependent variable y with respect to independent variable. What does it mean? What is the meaning of derivative? In fact, you are not the student of mathematics. Don't go in too much detail. Simply, as a student of business and commerce, derivative simply represents the instantaneous change in the dependent variable whenever a change in the dependent the derivative represents the change in the dependent variable, rather instantaneous change in the dependent variable whenever a change in the independent variable is being done, right? With respect to, this is very important term here, with respect to means, for example, you are studying in your class and you are securing say 98% marks in your class. So you are leading with respect to the students of your class, not throughout. So that is the same here. Whatever change in x is being done, the corresponding change, how much change will be noticed in the dependent variable y, such rate of change in the dependent variable with respect to independent variable is called as derivative of the function, which is being denoted by dy over dx. This is not only notation to denote the derivative, rather if you go through the different books, you will get the different notations. Like this, one notation is dy over dx, no problem. In second way, if y is equals to fx is any function. This function we have taken, the first derivative is this dy over dx. We can also denote y prime as a derivative. We can also denote it as f dash or f prime of x. In some books, we read it as f dash x, or in some books, we read it as f prime x. D over dx, this is also the notation. So a number of notations for the term derivative are available. You can use any one of them. Finally, if fx is any function, then its derivative is represented by f dash x. I have taken this notation, no issue. Out of these four notations, we can take any one of them. And the formula for finding out the derivative is what? Limit delta x tends to 0, f of x plus h minus fx divided by fx. This is the formula to calculate the derivative of any function. I have told you we will remove this delta x if you are getting any problem with this new term. You can also use this formula. F dash x is equals to, take h instead of or in place of delta x, limit h tends to 0, f of x plus h minus fx divided by h. This is the formula to calculate the derivative of any function. So you should keep in your mind this formula. What does it mean? Fx is the original function which will be given to you in the question, right? What you have to do next? Simply find out the value of f of x plus h. How you can find out the value of f of x plus h? The value of f of x plus h can be calculated by replacing all the terms of x by x plus h. Only the terms of x will be replaced by x plus h. The rest constant numbers will remain as it is. In other words, whenever you are having x in the given function, put x plus h in place of x, right? So if x will be given to you, you are able to calculate f of x plus h, put the value of f of x plus h and fx divided by h, find out the limit of this function at the right hand side by using any one of the methods which we have already discussed. What else you will obtain, that will be the limit of the given function, and that will be known as the derivative of the given function, right? So keep this formula in your mind. We will also explain this formula by further giving suitable examples. For example, the derivative can be calculated by the method of first principle. This is the method which helps us to find out the derivative of the various kinds of functions. After calculation of the derivative by using this formula, we can also remember some standard functions whose derivatives are also known, right? But this is the only way out. Second thing is, what is the differentiation? Differentiation is simply the process of finding out the derivative of the various functions, right? The process of finding out the derivative of the various functions is called as differentiation. Now we will find out, we will use the differentiation from the method of first principle. Yani how we can find out the derivative of the various functions using the method of first principle. The method of first principle, we will use the same formula as we have discussed in the last slide. The steps of this formula runs as follows. We have given a function y is equals to fx, then y plus delta y is equals to this. Subtract 1 from 2, you will get this, and then this is your formula. Finally, this is your required formula, right? Or you can use the same thing as I have just explained. In the given question, you will given this fx will be given to you. Simply find out f of x plus h by replacing all the terms of x by x plus h in the given function, right? Substitute the value of this and this here and here divided by h. Find out the limit of this function. What else you will get? That will denote the derivative of the given function, right? Let us take some examples. Example 1, find the differential coefficient of xn where n is any constant, integral or rational number using method of first principle. Here n can be any number. You can have a positive number, n may be negative, n may be 0, n may be any number, right? This formula is true for all the functions. Before proceeding the numerical questions, let me clear one thing. Differentiation is a very wide process. We can find out the derivatives of almost a number of functions. But here, being these students of commerce, you have to find out the derivatives of three kinds of functions. Number one, algebraic function. Number two, exponential function. And number three is logarithmic function, right? So we will find out the derivative of three kinds of function: algebraic, exponential, and logarithmic functions. So let us first consider algebraic functions. Algebraic functions are those functions which involve the variables and their powers, right? All the equations, all the polynomials are algebraic functions. So all those functions which involve the variables or their powers, they are known as algebraic functions. So x raised to the power n is also an algebraic function. Let us see how we can find out its derivative. See, f of x is equals to xn. This is given to us. Find out f of x plus h, right? See here, f of x plus h is obtained by replacing x by x plus h in the given function. So here x power n, x plus h power n. Simply replace x by x plus h and nothing else, right? So this is equation 1, this is equation 2. By definition of the first principle, f dash x, you know, this is the formula of the derivative. F dash x is equals to limit h tends to 0, f of x plus h minus fx divided by h. This is the value of f of x plus h, and this is the value of fx. So put these values, what we will get? We will get this limit h tends to 0, x plus h raised to the power n minus x raised to the power n divided by h. Now we have to find out the limit of this function, right? Look at this function. We will find out the limit of this function using the known result which we have used in the last lecture, that is written here. We will use this formula to find out the limit of this function. And this formula is what? Limit x tends to a, xn minus an divided by x minus a is equals to nan minus 1. But what we are having here, limit h tends to 0, x plus h raised to the power n minus xn divided by h. Now we will change our denominator h as per requirement of the formula. See here, we know that as h tends to 0, naturally, if h tends to 0, we are adding a number both sides. H plus x will also tend to 0 plus x. So 0 plus x means h plus x will tends to x, right? This. The same thing we have used here, as h tends to 0, x plus h tends to s. Thus limit x tends to h, limit x plus h tends to x. This tends to this, x plus h raised to the power n minus xn. This h can be written as, x plus h minus h. So what is this? Simplify it. X plus h minus h, h and h will be cancel out. What is we get? X plus h minus x, x plus h minus x. This is minus x. This will be cancelled out. So what we get? We are getting h. So this formula has been transformed to this one. Now apply this formula, xn minus an. This is xn, this is an, this is x, this is a. The value of this is what? N minus 1. So here this is n, a is x, nxn minus 1. So the derivative of x raised to the power n is nxn minus 1. Now look at the application of this single formula which we have calculated by using the method of first principle. I have told you we are calculating the derivatives of algebraic functions now because xn is an algebraic function. So algebraic function xn, its derivative is what? Nxn minus 1. What happens here? This power n comes down and the power n itself reduced by 1. Right? This is what we are using here. This is the technique behind this formula. So this single formula is more than sufficient to find out the derivatives of all algebraic functions. Right? We can find out the derivatives of all algebraic functions using this single formula. See what happens. If I write x raised to the power 3, what is n here? Here n is 3. So by this formula, its derivative will be what? 3x 3 minus 1. This is equals to what? 3x power 2. So derivative of x cube is 3x square. How we write it? Say fx is equals to x cube, then f dash x will be equals to 3x square. This is an example if n is positive. Now let us take an example if n is negative. For example, x raised to the power minus 5. Here n is negative, minus 5. To use this formula, what you will get? Minus 5 x power minus 5 minus 1, right? N x n minus 1. This is what? Minus 5 x power minus 6. And this can also be written as minus 5 upon x power 6. If any exponent is transferred from nr to dr or from dr to nr, its sign changes. So it is transferring, we are transferring it from nr to dr. So derivative of x raised to the power minus 5 is coming out to be this. You can take any number. For example, if I take x is equals to 3 by 2, take a fraction. If x is 3 by 2, by the definition, what is the derivative? 3 by 2 should come here and x power 3 by 2 minus 1, right? So this is what? 3 by 2 x power, what is left? 3 minus 1, that is 1 by 2. So this is the derivative of x raised to the power 3 by 2. So what this single formula shows actually, as I have told you, this single formula of x raised to the power n will help you to find out the derivatives of all algebraic functions. Means n is any power. N can be positive, n can be negative, n can be a fraction, n can be any number. Right? Second thing is what? We can have some numbers also. The second thing is what? Find the differential coefficient of y is equals to c. Yani what will happen or how we can find out the derivative of a constant. And we know that the derivative of a constant is 0. See at here, we have given the function fx is equals to c. C is a constant. And I have told you in the very beginning, constant quantities are those quantities which never changes. Right? So if f of x is equals to c, then f of x plus h will also remain c because c is a constant. It cannot be changed. Now by the definition of the derivative, f dash x is equals to limit h tends to 0 f of x plus h minus fx divided by h. Substitute the value of f of x plus h. The value of f of x plus h is c. So here c minus c upon h. C minus c is 0. So derivative of a constant number is 0. But be careful, derivative of a constant number is 0 if it is alone. If it is with any variable, then it will not be a 0. For example, if I write fx is equals to 5, 5 is a constant, then its derivative f dash x will be 0 by this result. But if I write fx is equals to 5x square. Here the number or the constant 5 is being multiplied with x square. So its derivative will be f dash x. This 5 will remain as it is. Write down the derivative of x power 2 using the formula of x raised to the power n. What it would be? 2 into x, that is 10 of x, right? So be clear, whenever a number is alone, its derivative is always 0. But if it is multiplied with any variable, then we will not differentiate the constant, rather we will find out the derivative of the variable, right? Let us take the derivative of this also. Find the derivative of the following functions from the method of first principle. We will use the same technique. I cannot explain the process of each and every question because of the lack of time. So the function is given here, f of x is equals to x square plus 5x. See, we have f of x is equals to x square plus 5x. Find out f of x plus h. Replace x by x plus h. Here, fx is given as x square plus 5x, right? We want to find out the value of f of x plus h. And to find out f of x plus h, we will replace x by x plus h. So here x square means x plus h power 2. This 5 is a constant. It will remain as it is. In place of x, put x plus h. So this is the value of f of x plus h. Now, by the definition of the derivative, f dash x is equals to, we know that limit h tends to 0, f of x plus h minus fx divided by h. Put the value of f of x plus h and the value of f of x and then simplify it. Limit h tends to 0. This is the value of f of x plus h minus this is the value of fx divided by h. Simplify it. Here x plus h power 2. We will use the formula of a square plus b square. This is what? X square plus h square plus 2xh, right? So x square plus 2x x plus x square plus 5x plus 5h minus x square, and this will become minus. Some terms will be cancelled out. What is left? Limit h tends to 0, 2xh plus h square plus 5h divided by h. Now we can take h common from here. What is left? 2x plus h plus 5. H and h will be cancelled out. What is left? Limit h tends to 0, 2x plus h plus 5. Now use the method of direct substitution. If you remember, means put h is equals to 0. So what is left? 2x plus 5. So derivative of x square plus 5x is 2x plus 5 by the method of first principle. Now similarly, you can also find out the derivative of x square plus 1 upon x plus 7. This is the original function. Now similarly, find out f of x plus h. See, replace simply x by x plus h in the given function, right? So this is what? X plus h power 2 plus 1 upon x plus h plus 7. Now, by the application of the first principle, this is our formula. F dash x is equals to limit h tends to 0, f of x plus h minus fx divided by h. Put the value of f of x plus h and fx and then find out the limit as usual. This is the value of f of x plus h, this, and this is the value of f of x, right? Open this by the formula of f a plus b square, x square plus 2hx plus h square. This is 1 upon x plus h plus 7. This will become minus x square. This is minus 1 upon x minus 7. Something may be cancelled out. This x square will cancel, 7 and 7 will cancel. What is left? Limit h tends to 0, 2xh plus h square plus x. What is left? 1 upon x plus h and minus 1 upon x. So its common is what? X plus h is the common in between these two. So x plus h cancel. What is left? X. Here x and x is cancelled. We will get here x plus h. So this is what we are getting here. This is equals to limit h tends to 0, 2xh plus h square x minus x plus h. X and x will cancel out. What is left here? H. In denominator, we will have the same term divided by h. Now take h common from numerator. This is h. We have taken outside. What is left here? 2x plus h minus 1 upon x, x plus h divided by h. This h and h will cancel out. What is left? Limit h tends to 0, 2x plus h minus 1 upon x plus h. Now again we will use the direct substitution method, that is putting h is equals to 0. So what is left? 2x and then 1 upon c. Put h is equal to 0 here, you will get here 2x minus 1 upon x into x. That is 2x minus 1 upon x square is the required derivative of the given function. So in this lecture, what we have learned, we learned how we can find out the derivative of the various functions using the method of first principle. So dear students, we should stop it here and we will continue the remaining portion in the next lecture.